Hello everyone, welcome back to another video, and in this video I'm going to walk you through how I designed and 3D printed this welding product in just 2 days. So these are purge plugs, and I designed them and 3D printed them here in my basement. So essentially what these do is they have an O-ring seal on them, and they go into the end of whatever tube you're welding and act as a plug, so that argon can go in on one side, which is what this plug is for. This inlet right here is to tap the flange that connects to the argon tank, and then this plug has 6 small circular holes in them to allow oxygen and everything to kind of seep out, because what this does is argon comes in, pushes the oxygen out, and then it has a steady flow, and these holes are here to not compress the gas in there, because that would be bad. Now I obviously want some gas in there constantly, so that's why these holes are nice and small. But so this one, demonstrate up here, acts as basically a passageway into it while still keeping a seal down onto it. Now you might be thinking why you want argon gas in your welds, and that's because you can see the buildup here inside there. It's a little hard to see because my camera's not focusing. The buildup inside of there along the weld, and then you look at this side. So my dad rigged these up, and I made these plugs for him for his welding that he's been doing on his Camaro for a dry sump system. These are the oil pipes, and we don't want all this buildup right here in the oil pipes. And this buildup right here is caused by the oxidation of the metal that you're welding. And so this side, this weld right here, was done without plugs, without argon, and his plugs he used were basically just duct tape. So I mean, they got the job done for a little bit, but I wanted a better solution here. And then this side was done, as you can see here, there's much less buildup right there, and that's honestly as minimal as it will get, at least with our welding skills. So this side was done with the plugs, this one was done without. So letting all the oxygen in here is what caused this to bubble up inside, and that's why we want to do this. So the reason that this took me 2 days and not 2 hours is because O-rings and seals are very, very precise, and with 3D printing it's not as precise as you might need it sometimes. So I've had to go through several iterations, some of which I have here in this box, of different models, of different dimensions. Sometimes the dimensions on the inside diameter for the O-ring here change, sometimes the entire thickness changes, sometimes the thickness of this groove right here for the O-ring changes. There's been a lot of different design changes to get to our optimal solution here. So I've pulled up my oxygen or air exit plug, so this one right here. I designed these in Autodesk Inventor 2023 edition. As you can see over here, I've only had to use a few things to really get this built up here, sketched up, all extruded and revolved. So I'll explain what that means here in a minute, but after I'm done sketching in here, I take it over to my slicer, which I just used the Creality slicer. I know everybody says I should use Cura, but I have been too lazy to download that, honestly. But I'll export that from Inventor as an STL, throw it in here, get it into the right orientation. I'm printing these at 100% infill because they are an obviously functional part, so I want them to be as strong as possible. And because I don't have any ABS printing in PLA, that's for the best. I've been printing at 300 millimeters a second to get this done as fast as I can, because my printer will do that. So I want to use that to the best of its abilities. And I've been using support underneath here as well. I'm trying to keep this face as flat as I can, so that it sits down on the pipe good, and then supports in the groove so that there's no mess in there for the O-ring to have some sort of blockage so that it can't sit down in there all the way and cause a problem. So I've been using all the supports. So this one, it's telling me 1.5 hours. This was an older iteration. That's why you can tell this is a little different, because this is my air inlet plug. So an extrusion in a Venter is basically a straight cut. So these holes right here are extrusions because they're cut straight down all the way through. These grooves are extrusions because they were cut out of the main thing straight down all the way through like that. And a revolve is basically where you draw a sketch and then the sketch circles around like this on an axis, and then you have your object because it turns that sketch into a 3D model as it rotates. And that's how I made the rush shape of this. So essentially when we are welding, we're going to end up something that looks like this. A bit like this, because obviously our tubes won't be this small, and we'll be welding joints as well. So one of these might be like in an elbow right here, but this is the general setup here, like I explained at the beginning. This took, I think, 6 iterations, so that was a total of like 7 or 8 3D prints, because 1 or 2 of them messed up. I comically left my printer on all night thinking that I had started the print, but I'd actually just heated it up. So I'm sorry, Ender 3. I'm sure that was pretty painful for you to stay on all night with the heaters on. So make little mistakes like that can slow you down a little bit, but proud of where I got to. Now with this is a pretty simple design. I've drawn up more complex things, so it wasn't too difficult to design, just with how precise these have to be. So like I'll show you here, this gap is 0.189. That's a pretty specific number. This surface, this diameter is 0.865. So another pretty random, pretty specific numbers. There was a lot that went into that, getting it all set up, but that's just what you got to do sometimes. And then obviously sent this to the slicer, waited hour and a half for each variation to print, tested it as I went, learned what adjustments I need to make, and then at the end we got a product that works. And this could be sold. I don't know if I'll be doing that, because I know there's a lot better ones out there, but just being as a garage welder, my dad wanted these, so I'm sure there might be a few other garage welders out there interested as well. But that's gonna do it for this video, guys. Thank you guys for joining me, and I'll see you in the next one. Make sure to leave a like and subscribe if you're interested in my content, and I work on a lot of cool stuff, so stay tuned.